Okay, as with all of the other lectures, this one will be recorded and posted to YouTube so that you can go through it later on. That is not an excuse to skip class, because if you're watching a YouTube video at home, you cannot ask questions. Okay, so please make sure that you attend. And besides that, random attendance will be taken throughout the year. If you miss too many lectures, you will not pass the module. Okay, so just keep that in mind with attendance at tutorials and lectures. That goes for the other modules as well. Okay, so we are going to continue with functions. Now we're going to be looking at piecewise functions. So a piecewise function is very similar to what we had last time. Remember, we had a set x, a set y, and we had a rule that told us how do we get from set x to set y. That was your straightforward function. With a piecewise function, it's a bit more general. It allows us to define different rules for different parts of the domain. So some part of the domain could have rule 1, another part of the domain could have rule 2, and yet another part could have rule 3. So I'll start off with an example just to illustrate this idea. So let's say we have a function f of x, and we want to define 3 different rules for 3 different parts of the domain. We do it like so. So we have an open curly brace. This shows us the list of rules and where they are defined. So let's say that this function is 0 when x is less than 0. Okay, so that's one part of the domain. When x is less than 0, that's how the function is defined. 1, when 0 is less than or equal to x, less than or equal to 1. And then let's go back to 0 when x is greater than 1. We see that this function definition has 3 parts, 3 rules, and then on the far right there, we see the 3 parts of the domain. So let's have a little sketch of the domain, and then we'll see what this function will look like. So over the entire x-axis, we see that it's now chopped up into 3 parts. X being less than 0, we have 1 part. Between 0 and 1, that's another part. After 1, we have another part. So let's put those points down. So let's say this is 0, and this is 1. So that's along x. Now, if x is less than 0, not including 0, that is a strict less than, the function is 0. Okay, so we go all the way along. It's 0, it's 1. Okay, it's 0 all the way along, so we're following the axis line. The function is 0. Not including 0, so we put an open circle. So at that endpoint, an open circle means the function is not defined there. Okay, there's no graph point at that point there, so open circle. If the function is defined there at the endpoint, we put a closed circle. Okay, so from 0 to 1, we see that that is including both boundary points. 0 is included, 1 is included. So at 0, the function is 1. Because now we're looking at the second part. So here the function is 1. We have a closed circle because that's what the function value is there. The function value is not 0 because we see x being less than 0. We're not including 0 there. So between 0 and 1, it's the constant function 1. Okay, up to 1. And again, closed circle at the endpoint because we see in the domain there, it is including 1. Okay, x being greater than 1, so after that point now, the function goes back to being 0. And at that endpoint, at the 1 point over there, it is an open circle. Why? Because x is strictly greater than 1. Not including 1, so we put an open circle. Open circle, and then the function will be 0 afterwards. Okay, so this is a very simple example, but this is how you need to think of these piecewise functions. We have a list of rules given by the brace over there. So 0, it's just the 0 function, the 1 function, the 0 function again, and on the right-hand side there, we have which piece of the domain has that rule. Okay. Anybody confused so far? Okay, please put your hand up if you're confused. Okay, like I said before, if you're quiet, I'll move on. Please, if you are confused, let me know. I can repeat this, and then we can move on with everyone following. Okay, let's have a look at another one. So here we have f of x. That's new page here. Okay, but it's the same idea, right? So whatever function you're given, Okay, so here f of x is equal to, again, we have the open brace, and this is where we list the rules on each part of the domain. So here we have x when x is less than 1, and again, strictly less than 1, we do not include it. 1 is not part of that first rule. So on that subdomain for the first part, there is no 1, not there. Okay, and then on the second part, we have x minus 2 squared for x greater than or equal to 1. Okay, for that second part, it could be equal to 1. So that is where we use 1. So when x is 1, we use the second part, not the first part. Yes?
So the open circles includes that number, and then... Oh, no.
Yeah, so the open circle will be for the first part, because it's not for that endpoint at 1, we put the open circle there, and then for the second part, that would be a closed circle. Okay, so let's have a look at what this will be. Same thing as before, we have x and y. So we start off with the x-axis to see where our subdomains are, and then on each subdomain, we sketch what's given. So here, when x is less than 1, we have the function x. The function x is straightforward. Whatever comes in, goes out. So that's going to look like this. Okay? So it will be from minus infinity all the way up to 1. We stop at 1, and we do not include 1. That is not part of the graph there, so that would be an open circle. Okay, so you can put an open circle there. Okay, next part, x minus 2 squared. What is that going to be? Let's see what that will be at 1, and then we'll see what it will look like after that. If we substitute x equals 1, which we can do because it's included in that subdomain, what do we get? Anyone? 1. Good. So at this point, we can put a closed circle now, because this closed circle is for the second part. So they kind of overlap. But overlapping an open circle with the closed circle, we end up with a closed. Okay, and then this will be a parabola, something like that, with the minimum there at 2. So we see here, in the previous case, we had this jump. If we go back here, from 0 onwards, we had a sudden jump from 0 to 1. Okay, but that's fine, right? Because each part of the function is defined on its subdomain. Doesn't matter what the other subdomains are. Over here, we have the same thing. The function is defined on its subdomain from minus infinity to 1, another function from 1 to infinity. It just so happens in this case that they coincide at that point. So we don't have that jump. Okay, does that make sense? Anybody lost with that? Do you see how they coincide at that point? If we look at the function that is before 1, the value should be 1. After 1, we use the other function, and they both have the value 1. So they coincide over there. Okay, but that might not necessarily happen, right? We could have something where there's a jump. Just happens in this case, they coincide. Yes? Okay, so remember when I first drew the first bit, we had the line x goes along up to the point 1, but we do not include 1. It's less than 1. So we had the open circle. So for that part of the function, 1 was not included for the first bit. For the second bit, that point is included. right? But they have the same value. So it's like having an open circle for the first bit, and then we overlap it with the closed circle for the second bit, so we include it for the second part. Does that make sense? Okay. Okay, so sometimes it will coincide like this, other times it won't. Like in this example, we get the step. It doesn't matter. The function is defined on its subdomain. That's all you need to worry about. If you have another subdomain, it might look different. That's fine. You draw it for its subdomain. Okay, let's have a look at another one. Okay, so this one is a special piecewise function, but it's exactly the same idea. You have one rule for one part of the domain, another rule for some other part of the domain. But this one comes with a special name, absolute value of x. You might have seen this before. Okay, so we can define this as a piecewise function as x, if x is greater than or equal to 0, minus x if x is less than 0. Okay, has anyone seen this before? Okay, has anyone seen absolute value before? Okay, one person there. Okay, cool. Okay, even if you haven't seen it before, it's just a piecewise function. It's just got a different name, different symbol that we use. Okay, so the two vertical lines with x, that's how we write the rule. It's just like how we can have square roots of x. Right? You can draw the square root, you put the x inside, it's just like that. Okay, it's just another math symbol. And that's how this is defined. So it's going to be x, so whatever you put in, you get out, for x being greater than or equal to 0, and it will be minus x if x is less than 0. Okay, so let's sketch this and see what this function does. Okay, we have x. 0, that's an important point. We see that that's where it transitions from one function to another. So let's say 0 is over there. Okay, first part of the function, x is greater than or equal to 0. We just have x. That's just a 45-degree line. That's very easy to do. It's just going to be like that. Okay. And we include 0 because it says we must include 0. No problem there. Okay, what about x being less than 0? Now we have minus x. Well, that's also a straight line, but now it's slanted the other way. So it's going to be like this. Okay, and then you can put the y-axis down the middle if you want. Okay, so we have x, y. Yes?
How do we know that it will be 45 degrees, 0, like?
Oh, that's just because y equals x. Okay, it cuts it right through the middle. So if you go from x-axis to y-axis, that's 90. Because it cuts it through the middle, it will be 45. Okay, you don't need to know that for now. We'll do that later. Okay, so this is what the function looks like. Now, we can see why this is called the absolute value of x. So if x is positive, we get x back. So the absolute value of 2 is 2. The absolute value of 3 is 3. What happens if we put in a negative number? The absolute value of minus 2, well, we're going to take the positive, so it's 2. The absolute value of minus 3, we're going to be on the left-hand side there. We take the positive, it will be 3. So the absolute value of any number is just the positive of whatever that number is. Does that make sense? Okay, do you see that from the graph? Whatever you put in, you get the positive version out. Okay, that's what we mean by absolute value. Okay, anybody lost with that? Okay, everyone's following along. Okay, so that's just roughly an introduction to piecewise functions and how to sketch them. So we've given the function in terms of a list of rules, list of expressions, and where to sketch them. So on the right-hand side, that tells you where that function bit needs to go. And then you just put them individually down like we did. Okay, let's have a look at some more complicated examples and look at the domain and range of these functions. So far this has just been sketching. Now we want to see what is the domain of these things, what is the range of these things, like we did previously with those other functions. Okay, so domain and range. Okay, domain is quite easy because in the piecewise function definition, it tells you what the domain will be. Okay, the only issue is finding the range. That's a bit more complicated. Okay, so let's have a look at this first function. F of x is equal to, and again, curly brace, and then we list the rules and where they go. So we have x plus 3. Where do we use this? It's going to be when x is greater than 0. And then for the other part, we have minus x when x is less than or equal to 0. Okay. So we see here the domain is all of the real numbers. Why? Let's look at the first part. X greater than 0, that includes all of the non-negative numbers, right? Anything positive, not including 0, but anything afterwards, that's included. So that's the first bit. What about the second bit? X being less than or equal to 0. Well, that includes 0, which we left out from the first part, and everything smaller. So if we look at everything after 0, and everything before 0, well, that's just everything. So the domain is everything. For that second part, if I put x less than 0 and not less than or equal to 0, that means out of all the function definitions, 0 is not included. Well, what happens if 0 is not included in the function definition? It's not in the domain. Does that make sense? Okay, so we look at the subdomains on the right-hand side, and we just union all of them together. Okay, and then that will give you the full domain. So the subdomain for the first bit, union the subdomain for the second bit, and the third bit, and so on. That gives you the full domain for the function. Yes?
So you were saying when x equals 0 is included, so you write that there by the domain and say x
Yeah.
does not equal to 0.
Yeah, so we can have something like this. X plus 3, x greater than 0, minus x, x being less than 0. Okay, so everything else we keep the same. Here, the domain, we can write as the real numbers minus 0, if you want to write it like that. That's fine as well. Remember back when we looked at sets and set comprehension and all that, a set minus another set, we defined that. We did an example with that as well. You can write it like that if you want. You can write it as the union of two intervals if you want, or you can write it in terms of set comprehension. That's fine as well. Okay, but get used to writing it many different ways. You don't know what might come up in the test. Okay, so I could give you the domain written like that, or I could give you the domain as the union of two intervals, or I could give you the domain as a set comprehension. You need to understand what those mean. Okay, but that's just on the side. Here we are including 0, so we have everything there. Okay, what about the range? Well, an easy way to find the range is to sketch the function. If you know what the function looks like, you know what values the function maps to. So let's do that. So sketching the function is always the easiest way to see what's going on. Okay, x plus 3 for x being greater than 0. So we're going to start at x as 0, but remember, open circle, not including it, and it's going to be x plus 3. So again, 45-degree line, shift it up by 3. That's going to look something like that. Okay, we're not including x equals 0, so that's an open circle. It does not form part of that subdomain. And then it's just a 45-degree line going out like that. Okay, the next part, minus x, that's easy. We sketched that in the previous example. Here we are including 0, so it's a closed circle for that endpoint. Okay, let's try and get this nicely there. There we go. Okay, so on the side here, we have y equals x plus 3. And on the other side, y equals minus x. Okay, now that we've sketched it, it doesn't need to be a neat sketch, but we can clearly see what's going on now. We can see the domain along the bottom, and we can see the range going vertically. Okay, so firstly, notice how nothing is negative, right? So that's the first clue. Whatever the range is, it has to start from 0 and go up. Okay, including 0, because that's part of the domain. If we put minus 0, we get 0, so that's part of the range. Okay, so let's move up now from here and see which y values do we actually reach. So from here to here, we see that y equals x plus 3 contributes nothing to the range. At a half here, let's say there's a half there, we cannot reach that using x plus 3. Not going to happen. So this part contributes nothing to this part of the range. What about this part, y equals minus x? Okay, can we get to a half? Just as an example. Can we get y equals a half? There we can. If x is minus a half. If x is minus a half, the y value is a half. Okay, what about y equals 3? Can we get that? Yes. If x is minus 3, y is 3. So that's part of the range. So if you just like project this over, we see from here all the way to infinity, this section covers everything. The section on the right does not include this part, but includes everything after. But we need to consider both of them together. It's the union of the two. What can we get to with the first part? What can we get to with the second part? Does that make sense? Yeah. So, the range is equal to the values we can reach using the first part on its domain. Let's say x plus 3. We said that was the first part. What can we reach with that function on its domain? Can we reach 3? No. Open circle. We cannot reach 3. Can we reach anything above 3? Yes. So that's going to be from 3, open bracket, not including 3, y, open circle. It's not there. Point does not exist for that function. All the way to infinity. Union, y union, well, we can reach other points a different way. So let's look at the second part, minus x. Can we reach negative 1? No. Okay, almost tricked you with that. We can't reach negative 1. Why? Because it's only in the top part. There's no way to get to negative 1. So is negative 1 part of the range? No. What about 0? Yes. 1? 2? 3? Anything positive? Okay, so we can go from 0, square bracket, and we can go all the way up to infinity. And we want to take the union. Remember what happens with the union? We take everything from the first set, everything from the second set, we combine it into one set, but remember sets can't have duplicates. So from 3 to infinity, and from 0 to infinity, is there any duplication happening? Think from 3 to infinity, that's my first set. 0 to infinity, that's my second set. Are there going to be duplicates? Yes, everything from 3 onwards. That's common. Okay, so what do we end up having with the union? We need to include everything, but not the duplicates. So what do we get for the union? Sorry? Okay, so the union, where would the interval start for the union? Will it start from 3 or will it start from 0? 0. Where does it end up? Infinity. Good. Okay. So we see that the range is everything, because if we pick any particular y value, the question to ask is, can we reach it? It doesn't matter which one we pick, it's just can we get there? So whether we use the first part of the function or the second part of the function, doesn't matter. Can we reach that point? Okay, like 3, y equals 3. We couldn't reach it with the first part, we could reach it with the second part, so it's included. Okay, everyone clear on that? Okay, who's not clear with this? Yes?
You asked me when you said about the duplicates.
Oh, by duplicates, if we just sketch this out here, so let's say we have the x-axis. Slightly above, I'm going to write the first interval from 3 to infinity. So let's say here's 0, here's 3. So 3 all the way to infinity. Okay, the second one is from 0 to infinity included. So here's 0 all the way to infinity. We see that at 3 onwards, it overlaps. So it's covered by that bottom one. You can think of it as the top one is a subset of the bottom one. So if you take the union, you just get the bigger one. Okay. Yes?
Question for other one, for the absolute function.
Yep.
Do you still have to show whether it's inclusive or not? Because I need to draw several absolute functions.
Absolute, let's go back here. For this one.
Yeah.
Yeah, so it will be,
For the circle, have 0 points.
yeah, that will be a solid dot. Yeah. If it's a solid dot, right, in the function like that, you can put it there to show me you know what's going on, or you can leave it out. That's fine as well. Yeah.
For both solid dots.
Yeah. So, like with this one here, that dot there, that's just to emphasize that that point is included. What's more important is if you put an open circle to show it's not included. Okay. That big dot there, that's just emphasis, right? You don't need to put it there. It's just emphasizing that the point is included. Okay. Okay. Any questions on this one before we move on? Okay. Let me warn you again. Please do not fall behind with this work. Next week, we will be moving on very quickly to get to where we should be. If you are confused with this part, when we get to calculus with continuity and derivatives, you're going to be completely lost. Okay. Please make sure you understand what's happening here. Okay. Let's look at another one. Okay. Here we have the function 2x plus 4. This is for minus 4 less than x less than 0. And 5 minus x minus 1 squared, 0 less than x less than 2. Okay, and again, we're given this function. Our job is to find the domain and range. Okay, let's have a look at the domain first. There's the subdomains. We've got an interval for x for the first bit. We have an interval for x for the second bit. The domain will be the union of the two. Because it's one function, we union the parts together. Okay, so with that in mind, what will the domain be? -4 to 2, not quite. Have a look at the strict inequalities there. None of those values on the boundary are included. So it will be -4 to 0, and then 0 to 2, not including any of those endpoints. So the domain, -4 to 0, open bracket, because nothing is included. There's not one equal sign there. Union, right, because we want to look at the full domain. 0 to 2, again, open brackets, because we are not including any of that. Okay. If you want to be a bit creative with this, we could also write it as -4 to 2 minus the singleton 0. Okay, that's another way of writing it. It means exactly the same thing, and you need to understand that it means the same thing. Okay, so I'll just put a little star here. It's just a little creative way of writing that, but you should know exactly what that means. Okay, anyone confused about this domain? Okay, so everyone's fine with that. Okay. Question? Okay. Anyone? Okay, so that's the domain. Let's look at the range. Like I said with the previous one, the best way to examine the range is just to sketch it. And then you can actually see what's going on with these functions. Okay, so let's get our Cartesian axes going, x and y. Let's look at the first part, from -4 to 0. So let's put those points down. They'll be important. So -4 and 0. Okay, now we want to sketch this line, 2x plus 4. Okay, we have a rough idea of what a line looks like, but what is it going to look like on that subdomain, right? We're not drawing the whole line, we're drawing part of the line within that interval. Okay, so when x is -4, so we're looking at the left endpoint there, what is the y value going to be? -4, good. So at -4 here, we can put an open circle. Why open circle? Well, because the function is not defined at -4. But that's what it would be if it was defined. So we can put an open circle. Okay, what about 0? 4. At 0, it will be 4. Again, open circle. Why open circle? It's not defined there. But that is the value it would have if we continue it a little bit to that point. And it's a straight line. We can just draw a straight line between these points. Okay, very easy. Straight line between the two endpoints. Open circle, those points are not included. Yep. So -4, I put x equals -4, and then I got the answer of -4. So you put in -4, you get 1 point. You put in 0, you get another point. 2 points, you can draw a line between them. Okay. What about the parabola over there? Same idea. We're going to look at the endpoints and see roughly what this is going to look like. Okay, when x is 0, what do we get? 4. Okay, we've already got a circle there for 4, so I'm going to leave it out, but you would put that in. What about at 2? Yeah, we also get 4. Open circle at 2, 4. So here, let's say that is 2. There. Okay, so the parabola lies somewhere between there. What does this parabola look like? First of all, it's a sad face parabola. Why? There's a minus in front of the x squared. Okay. Next, there's a turning point at 1, 5. Why? Well, it shifted 1 to the right. It shifted up by 5. The turning point is at 1, 5. If you cannot read that immediately, please go back to your high school work on graphs and shifting. Okay. You shouldn't need to do any calculations on the side. Knowing that the turning point is at 1, 5 should be immediate. Okay. Again, please look at the matric help guide. It is posted. All of that is covered there with examples, exercises, and explanations. Okay, and 5, so that's somewhere up there. It's going to look something like that. Okay. You should be able to sketch this with no hesitation. Okay, again, if you cannot do this immediately, if you have hesitation with what does a parabola look like, is it happy face, is it sad face, go to the Matric help book. It's there. There's explanations there. There's exercises. There's examples. And most of the time I'm in my office. Come to me if you need help. Please do not fall behind on simple things, because if you can't sketch this, we haven't even got into answering the question yet. Okay, it is very important that you can do that. Okay, so the range. Let's just zoom out a bit here. So, to find the range, we ask ourselves, given a particular y value, can we get there with some x value? If we can get there, it's part of the range, right? Because x got us to the y. If we can't get there, it is not part of the range. Y equals minus 5. Is that part of the range? No. Why? Because if we look going down, the function stops here. Y equals minus 5 is here. We don't get there. If we don't get there, it's not part of the range. Y equals minus 4. Is that part of the range? No. Who says yes? Who says no? No. Why? Open circle. It is not included. It is not part of the range. Y equals minus 3. Yes. Why? It's going to be somewhere here. Okay. Y equals 0. Yes. It's right here. Okay, you just look. It's right there. Okay. Y equals 2. Yes. Y equals 4. No. Why? Open circle for that first bit on the left. Open circle for the second bit on the right. There's no way we're going to get to 4. Y equals 5. Yes, it's the turning point. That's included. Okay, so what is the range going to be? It's going to be from here up to there, not including this point, including that point, but not including 4. 3 things we need to keep in mind with this. Okay, so let's write this out. Range. What did we say? From minus 4, not including minus 4. So that's open brackets. We could get all the way up to 4. All the way up to 4, but not 4. Union. Why union? Well, we're trying to combine all the ranges together. And then for the last bit, with that little bit of parabola, 4, not including 4, up to 5, including 5. Why? It's the turning point. It's included. Okay, and if you want to be a bit creative with this, we can write this as the interval minus 4 to 5 minus the singleton at 4. Yes? Oh, sorry, yeah, that's the square bracket there. Okay. Yeah, so that reminds me, when you are writing these round brackets, square brackets, please be quite neat with it, okay, so that I can see, did you mean a round bracket, did you mean a square bracket? Yeah, that would be the same for the bottom, yeah. Yeah, so those should be square brackets because we include it. All the other ones are round brackets. Okay, make sense? Okay, so whenever you want to find the domain, you don't need to sketch anything. We just look at how it's defined. Here we see subdomain number 1, subdomain number 2. If the function is defined on this bit and on this bit, the whole domain is the union of the two, because we're combining it. What about the range? You could work it out separately, but sketching is just so much easier. So we do a sketch, and then we can visually see what it's going to be. Okay, so here, open circle, we include the top point. It's going to be everything from this open circle to the top point, but not including 4. Okay, so that's the range. That's the typical method that you should be using. Okay. So I prefer the sketching because you can see what's going on. If you have another method, you learn something online or whatever, if it gets you the right answer, that's fine. Okay. You don't have to sketch it, okay, but that's just what I like. Okay, because then you can see what's happening. Okay. Any questions before we move on to the last example? No. Okay, so the last one, this is going to be 2x plus 1, absolute value. Now, I've just written that down. I haven't written it in terms of a piecewise function, but we know that this is a piecewise function. So we can expand it out, if you want to think of it like that, into its pieces. Once we know the pieces, we can union them to find the domain. We can union the ranges to find the range. Just as written here, it's a bit difficult to work with. Later on, when you get more experience, you can do it right from here. But for now, we're going to write everything explicitly. Okay, so this is going to be equal to what? Remember how the absolute value of something is defined. It's going to be that something if that something is positive. It's going to be minus that something if that something is negative in order to give a positive result. So that something here is 2x plus 1. So it's going to be 2x plus 1 if 2x plus 1 is positive. Not if x is positive, if the entire thing is positive. Please do not make that mistake. The absolute value goes over the entire thing inside, so that entire thing inside must be greater than or equal to 0. Not just x greater than or equal to 0. Does that make sense? Okay. And it's going to be minus that something, so we just put minus in front of that whole thing there, if that something is then less than 0. So that whole thing, 2x plus 1 less than 0. Okay, makes sense? So in the previous example with absolute value of x, we're now replacing x with that whole expression. So before we had minus x when x was less than 0, now we have minus the whole thing when the whole thing is less than 0. Okay, I hope that is very clear. Yes? Equal to is in the top portion where it's positive. Okay, you can put it at the bottom, that's fine as well, you get the same thing. I just like to put it at the top where the thing is positive. Okay. But as we saw from the graph, the left-hand side and the right-hand side coincide at 0. So that 0 can be on either side, but it can't be on both, right? The function has to be on its domain and another domain. You can't have the equals mentioned for both. Make sense? Okay, quick example on that. Let's say we had a function like this. Okay, I'm saying that point belongs to both. Now, this isn't a function anymore. Let's say this is 1. So when the function is less than or equal to 1, we're on the left branch. When the function is greater than or equal to 1, we're on the right branch. What happens at 1? Do we use the top or do we use the bottom? We don't know. So it's not a function. A function needs a unique output. So here, this is not a function. Do we go up or do we go down? It's not clear. This is completely wrong. Okay. This is why a given point on the boundary must belong to one and only one subdomain. Okay, let's go back to here. Okay, so that's why the top part has the equals and the bottom part doesn't. You can swap them in this case only, but rather just leave it like this. Okay, so we can expand this out a bit more. Okay, so this is equal to Okay, we're going to have the same thing, 2x plus 1. Okay, now the 2x plus 1 greater than or equal to 0, we want to now solve for x. Why do we want to solve for x? Well, because x is part of the domain. Okay, so we can take the 1 over to the other side, divide by 2, x is greater than or equal to negative a half. Okay, and for the other one, let's put minus 2x minus 1. Okay, similar thing. We take the 1 over to the other side to get minus 1, divide by 2, minus a half. X is now less than minus a half. And this makes it very clear what the domain will be. Let's look at the first part. X is greater than or equal to minus a half. That subdomain is going to be an interval from minus a half, equaling minus a half. We include that point all the way to infinity. The second portion, or the second part of the subdomain, x is less than minus a half. So we're going to go from minus infinity up to minus a half, not including minus a half. We're going to union them together. Does anybody not see that? Okay, please don't be afraid to say you lost. I will go over it again. Yes. Okay, where did I lose you? Okay, so over here, let's just go back a little bit. So here we had this expression, 2x plus 1 greater than or equal to 0. We want to solve for x. Why do we want x? Because x is the domain. The x values are the domain. So a little bit of rearranging, we get that. Make sense for that part? Okay, same thing for the lower bit. 2x plus 1 less than 0. We want to find the x values. That gives us the domain. Again, a little bit of rearranging, we get minus a half. Okay, so we can write this as intervals. So the domain for the first bit, what is the domain for the first bit? It's everything after minus a half, including minus a half. Okay, so here, okay, so it's going to be from minus a half to infinity. Everything at minus a half onwards. That's what it means for x to be greater than or equal to minus a half. Okay, and then the other one, x is less than minus a half. So it's all of the negative numbers all the way on to minus a half, but not including minus a half. So we can write this as union minus infinity to minus a half. Okay, not including. But notice something with this. For the second interval, we have minus infinity to minus a half, not including. So that's like all the negative numbers up to minus a half. For this first bit, it's minus a half including, and then all the way up to the positive numbers. So we have everything up to minus a half because we're including it here, and everything after. So what's the domain going to be? Everything up to minus a half, including minus a half, everything after minus a half. Did we leave anything out? No. So what's the domain? Everything. All real numbers. Okay, is that not clear to anyone? Okay. Okay, so that's the domain. Same thing as we did last time. We look at the subdomains, we take the union of the subdomains, we get the full domain. Okay, last bit, looking at the range. Now, we could, do a whole long calculation and so on. We could sketch it, but finding the range is actually very easy. Why? Because it's the absolute value of something. Doesn't matter what that something is. What does absolute value do? It gives us back the positive. can we get negative 1? Can the absolute value of anything be negative 1? No. Can it be 0? Yes, it can be 0. Absolute value of 0 is 0. Can it be 1? 2? 3? Any positive number? So what's the range? Yeah. Good. So the range, 0 to infinity. We didn't even need to sketch it. Why? Because we know what the function does. You could sketch it. You'll see you get exactly the same thing. Yeah. Yeah, so 0 is included here. Why? Because the absolute value of 0 is just 0. Okay. And that is specifically why, let's go back up here. That's why we include that less than or equal to part, is so that we can include 0. Okay. Any questions on this example? Yes. Okay, if I take the absolute value of minus 3, what's the result? 3. What's the absolute value of minus 1? 1. Will that ever be negative? No. If you take the absolute value of anything, it gives you, by definition, the positive of that number. So we can't get negative numbers. Okay. Or if you stuck with that, we can look at the graph. The graph only exists in the positive part. Nothing is in the negative part. So that's not part of the range. But 0 here, that is included. Okay. So if you're ever stuck, think about the definition in terms of piecewise functions, or do a sketch. Okay. Some people like the definition, some people like to see the sketch, whatever works for you, just so that you can see what's going on. Okay, I like to include both. Okay, any other questions? Yes. Okay, so absolute value. Whatever you put into the absolute value, you get the positive back. So here, if I put in a positive number, I get the number back because it's already positive. If I put in a negative number, let's see what happens here. If I put in minus 2, do I go to the top part or the bottom part? The bottom one. Why? Because minus 2 is less than 0, so I look at the bottom one. So I get minus 2, which is 2. Okay, if I put in 3, do I go to the top or the bottom? The top one. Why? Because it's bigger than 0. So I just return x. Okay, what about minus 5? If I put in minus 5, do I go to the top or the bottom? Bottom. What is minus 5? 5. So you see, it doesn't matter what you put in, whether you go up or down, you get the positive out. Okay, that's what this function is designed to do. Whatever you put in, you get the positive out. Make sense? Okay. Let's do a quick summary of what we did today, and then we can go. Okay, so piecewise functions. Okay, so given some function f as a piecewise function, it is made up of some number of rules on their domain. The rules do not mix domains. Rule 1, domain 1. Rule 2, domain 2, they never mix. And by rule, I mean whatever function you want to put there. Square root x, 3x plus 1, sine of x. Remember what we said about the rule. Yeah.
So when you talk about subdomain, what do you mean?
That's this bit here. So let's say we go from minus 1 less than x less than 1. That's this subdomain. Okay, because at the end, when we find the domain, we take the union of all of the smaller ones. And that gives us the big one. Okay, so here this will be, let's say rule 1, domain 1. down to rule n, however many there are, domain n, again, however many there are. Okay, those domains are the subdomains. It's the pieces of the x-axis that these rules apply to. So if we look at all the pieces individually, we get the subdomains. If we want the domain of f, that's the domain with everything included. Well, what is everything included? That's the union. Domain of f, domain 1, union, all the way up to domain n. We union them, okay? Right, we can union them, it's perfectly fine. None of them overlap. None of them intersect with each other. So unioning them, perfectly fine to do. What about the range? Well, same thing. We have one piece of the function with some part of the range. We have another piece of the function with another part of the range. If we want the total range, what's the union of all of the pieces? Okay, and I've showed you how to find the range of a function. You sketch it, see what it looks like. Maybe there's a minimum, maybe there's a maximum, maybe there's a point missing, doesn't matter. We union all of the ranges, and that's our total range. Okay, and that's it. That's all of piecewise functions. Okay, anyone still lost with this? Okay, I hope not. Okay, so tomorrow we'll do a little bit more on functions, and then next week we will start on composition of functions. Just another little bit of warning, if you do not fully understand domain and ranges, when we get to composition of functions, you're going to be quite lost. The reason being is, with composition, we have x going to y going to z, like this. So just a little bit of warning before that. We have the domain of f, which is x. We have the target of f, which is y, which is also the domain of g. So, how is this going to work? The range of f needs to be all of y, so that it can then, the range of f needs to be all of y, so that it can be the domain of g. And then that goes to z. You see, there's a lot of mixing going on here. If you don't know how to deal with the first part, dealing with the composition of these two parts, it's going to be crazy. Yes? Yeah, those are two functions, yeah. Okay, but this composition, joining them together, there's going to be problems at y, and we'll see that next time. Okay, but please, you need to understand domain and ranges so that we can fix the problem at y. If you don't understand it, well, there's no hope to fix that issue there. Okay, so we'll leave it at that for today.